Hello and welcome to today's video. So on the workbench I've got the Pack Sniffer. This is the version 1 that I've kind of started doing some modifications to it to help develop version 2. And I've redone the power supply on it, and I've added some out bits to control the two contactors and the precharge in the Nissan Leaf battery pack contactor assembly. I've also got a BMS, Nissan Leaf BMS hooked up, but I obviously don't have any cells hooked up. So it returns all Fs. I just did that for a load so that I can actually show that everything's, make sure I'm staying within the power budget of one of these little power packs. They limit me to 2.1 amps, if I can get that to focus. Maybe. Well, trust me, it says 5 volts at 2.1 amps. There you go, 5 volts at 2.1 amps. So the goal is to stay under that 2.1 amps. So I've redid the power supply section, boost converter, and main power supply. You can see I've got a kludged together inductor. This guy was not cutting it anymore, so it got removed. I couldn't pull enough current through it. I didn't actually have a big enough inductor either that would saturate, so I ended up with 4 inductors. They're in a series parallel configuration to essentially make a 47 microhenry inductor that can saturates around 3.5 amps or so. So that gets me into the ballpark that I needed. We have all the capacitors populated because we need pretty much this entire bank. I almost need to put more in there, but the next size up gets really close to the size of my standoff, and then yeah, see, this is the same diameter, but I get a little bit more capacitance without having to redo it, but that gets really close, and these little metal tabs on the display hang down and could hit it. So I haven't decided what I'm going to do with that yet, but probably could use a little bit more capacitance, but it does work. There's a little bit of ripple, and I can show that to you. Also down in here, I think you can kind of see there's some if I get to focus, there's some MOSFETs that I've put inside there. There's 3 MOSFETs, same ones that I used in the X-Tech power supply modification to turn on those relays. They do a couple amps a piece, and then the 3 diodes up on top are the catch diodes, so we don't blow up our MOSFET. And I've added this connector here. The 3 wires go out to the contactor, so we got the ground contactor precharge and the high side, or the positive battery pack contactor, and then the other pinouts is the same. We've got the 12 volts can high and low, and then ground. So it kind of just goes out on this cable around into here, and then into the actual Leaf battery harness there. So without further ado, we'll go ahead and fire it up. I've got the voltmeter on the output of the boost converter on the 12 volts, and I've got the scope hooked up to both of the high and low contactors, so we can see those PWMing. And I've got my power supply hooked up, my X-Tech one that I modded, and you can see I've made a handy dandy little USB adapter, if we get it focus, out of a spare USB. I took the data lines out so you can see it's just got the power lines in it. But that allows me to go ahead and do this, because that was a nice, yeah, that works. So that was just built out. But anyways, go ahead and turn it on here. We're going to hear a few clicks. I'm going to turn it on. It's going to boot up. It's going to power up the battery, the BMS first, and then it'll turn on this contactor, the ground contactor. It'll pre-charge, and then turn off the precharge, and then turn on the high side contactor. So you'll see the little power blips, and we're going to watch this meter. We're trying to stay under that 2.1 amps. So ready, set, go. So there you go. We're up and running, and you can see the this is the PWM going to the 2 contactors. 20 kilohertz, it doesn't make any noise, and both contactors are now on, and we're within our power budget. So I'll go ahead and do it again. So when it first comes on, it powers everything up and then turns on the low contactor, pre-charge, and then the other contactor. So there's about a 2-second thing. If I can catch it right, you'll actually see this jumps up to about 2.1 amps. But the display doesn't update very quickly, so I'll just keep doing it a few times. But see, it jumped up to 1.9. It's just at 2 amps, so we're under the budget. We won't kick out the one of these little power packs. But yeah, this video is getting kind of long, so I'm going to flip this around to the other side so you can actually see the display. Actually, I'll just pause it and do that real quick. Try to keep everything hooked up the same way and show you what's going on. You can see the boost converter under full load here is putting out 11.92 volts. And let me go ahead and pause it. Okay, I went ahead and curiously flipped it over so you can see on the back side. I can explain more of the power supply mods I did. You can see I've added in a 5-volt regulator here and put in, these are the 10K resistors that hold the gates to ground so they don't accidentally turn on the MOSFETs. And this trace, I cut trace down in here, the 5-volt trace, you can kind of just barely make out my, if I put it in the shadow there, that little line is where I cut the 5-volt trace, and that used to feed the boost converter, and now the boost converter is fed directly off of the 5 volts from the USB port here. So it goes right in there. And I can show you what that looks like right here. So let's see, where can I put this? Let's just do this. There we go. So essentially, before, the display, which runs at 5 volts, the backlight and everything, was running directly off of the battery pack. And then I was regulating down to 3.3 volts to run the microcontroller and everything else in the CAN bus. And the boost converter took the 5 volts in from the USB and also from the battery pack, and that was generating a separate 12 volts. That was causing some issues. I was pulling enough current to drop this thing. When you pull current, has a lot of ripple in it. And I'll show that to you later here when I run it off of this. A lot of ripple. And that was actually dropping below the 3.3 volts after everything, was causing my micro to glitch and kick out. So I redid the power supply, and this enables a few different things. So there's madness, or reason behind this madness. So 5 volts comes in now, and if the boost converter is running, it gets boosted up to 12 volts. That 12 volts is regulated with a linear regulator, 7805, down to 5 volts to run the display. Then, and I think the CAN bus runs at 3.3. And that 5 volts is then regulated down to 3.3 volts to run the micro. So that gives me a lot of margin here for this. But when power is first applied, we've got no load, everything's off. You'll see it goes through the inductor, through this diode, through the 78M or 7805 regulator is essentially full on past transistor, and then we go down and we eventually get regulated 3.3 volts. And that actually works pretty good down to 4.5 volts, and I can still get enough to get my micro to boot up. Once the micro boots up, it starts PWing this, and then this rapidly goes up, and I get a good 5 and a good 3.3. Display comes on, everything starts up and running. So this allows me, and it may seem ridiculous to take 5 volts in, boost it to 12, and then regulate back down to 5, but it actually cleans this up a lot, and I don't have to worry about the ripple current, or the ripple that's occurring on the 12 volts anymore. It also allows me to, this 12 volts can be exposed, so if you don't want to use the 5 volt regulator boost converter, you can just, like if it's inside of a vehicle, you can just put 12 volts in here directly, and everything will still run. So you literally don't need this part anymore. You can just run it with 12 volts from your car, and that'll power up everything, and it'll work fine. It also has the added benefit, if you watched the last video, I had to always eject the USB drive in order to, so I wouldn't corrupt it. If you don't do that, if you just yoink it out, it was corrupting because I wasn't able to close the file system in time. because we had 5 volts coming in directly here, and it was just being regulated 3.3. So I only had what little bit of current or energy was stored from that 5 down to 3.3. Well, actually about 4 volts or so, whatever this guy kicks out at. In order for me to save, to close my file system and finish saving to flash, you just, pulled the connector out, because that's supplying it with power. So this gives me this entire capacitor bank. Oh, I flipped it over, but those 3 caps that are in parallel there are right here. So now I can wait for that 12 volts to decay and use up all that energy to keep my micro running long enough to complete all the save operations. So there is a method behind this madness. It does allow the system to actually work, handle power drops and things like that, and still function. So I'll go ahead and flip this on again now that we have the display. I currently have it set up just doing diagnostic stuff, so it's going to wait until it pre-charges, because I probably should have actually have it writing the display while it's doing it. But I'm updating it, the display faster than it likes, but you can see it thinks it's right at 12 volts, and then the PWM value, you can see it's flipping around there as it's generating the boost. So it's actually putting out 11.9 volts in reality. So there's some either losses in the traces, or more likely my voltage divider, the resistor tolerances aren't good enough to get it exact, but it's close enough. It'll work. You can see it's PWMing those, and yeah. So essentially what it's doing is the target voltage is 12. Any discrepancy, it's doing a PI controller, so you get proportional and integral gain that adjusts this PWM value, so it's kind of cycling around in there to try to maintain. When it goes a little above, it drops down. If it goes below, now the display is only updating at like 5 times a second, and that loop that does the PID is actually running at 10,000 times a second. So we're kind of getting a little, it's probably doing a nice little sine wave, and we're getting like little random points on there is what's showing up there. But anyways, yeah, this video has ended up being pretty long, so go ahead and stop it, and I'm going to put this back to normal, reprogram it with the actual code, and then we'll see everything starting up. So thanks for watching. Bye.